Okay, this is our third and final video on functions. What we're going to do today is look at how we find the domain and range of a function based off of a graph. So we have one target for today. By the end of today's lesson, you will be able to find the domain and the range of a function when given the graph of that function. So it's important that you understand what domain and range represent. We've talked about these before. Just to recall, domain represents x values, range represents y values. So what we're going to do in today's video is we're going to look at a number of different types of graphs that you're going to see and how we represent the domain and range of each one of them. There are some, this can be a little bit more abstract and can be a little bit more difficult sometimes. So please, if you do have a question, pause the video, write down your question, and then continue on the video, or even go back and re-watch it if you need to. But write that question down so when you come into class tomorrow, you can get that question answered, and we can talk about it. So let's look at our first example, and that's just a line. Now, the key thing here is that it's a line and that you see on both endpoints, there's arrows. What that means is that this line will continue on in both directions forever. Okay. In other words, there are no limitations or restrictions on the x and y values. Okay. So one of the easier things to do is that if you were to draw a line down the middle, anywhere on the graph, okay, you'll notice that it keeps going on in the x direction forever, keeps going on, to the left and the right forever. If you were to draw a horizontal line, the graph goes up and down forever, both positively and negatively. Okay, so there's no restriction on it. It contains all possible x values, all possible y values. Okay, so how do we write that? So here we've got another line. Okay, there's no restrictions. This goes left and right forever. Okay, it goes up and down forever. No stops. Okay, sorry about that. So the domain here, we would say x is an element of the real numbers. Okay, so you may want to write this down. E represents an element of, okay, and that symbol looks like an R with an extra letter, represents the real numbers. Okay, what this basically means is that x can be any possible real number. There's no constraints, there's no stopping point. X can be any number. Okay, we just use those symbols, and you need to make sure that you are familiar with those symbols because you will see them on multiple choice questions and on the SOL. Okay, now the range is very similar. There's no constraints on the range. So here we're going to say y is an element of all the real numbers. Okay, so that's the easiest type. It's a line, it goes on in both directions, there's no constraints. All right, once again, we've got a line here, no constraints, no stopping points, goes on in both directions forever, both up and down, left and right. So we say x is an element of the real numbers, and y is an element of the real numbers. So let's do something a little bit different, okay? Parabolas, we've seen these before. These are the graphs of quadratics. Okay. So here the graph of a quadratic, we should already know the domain and range here. We've done this before, but just to kind of go back and refresh it, okay? With a parabola, there are restrictions on the y values, but you notice that you have arrows here, okay? So this graph's going to go left and right forever. There's no restrictions on the x values. But whenever you see a parabola, what you want to do is you want to put a point on that vertex, okay? Because that vertex, that's your limit on your y value. So if you were to draw a horizontal line where that vertex is, okay, and say, okay, what's the y value here? Well, the y value of that vertex is 0, okay? All my points are above 0. There are no points below 0, okay? So that means that the range, all of my y values are greater than 0. Okay? So how do we write that? Let's look at another example. So here we've got a parabola. Okay? We're going to start by putting a point on the vertex and then drawing a line through that point. Okay? Now we've got arrows, so this line is going to go off to the left and right forever in both directions. So there's no limits on the x, so we're going to say x is an element of all the real numbers. But you notice that there are no y values down here. So here our vertex is at a y value of 5. All of our y values are above that. Okay? So when we write our range, we're going to say y is greater than or equal to 5. Let's look at another example. This isn't a parabola, but it looks very similar. It's the graph of what we call an absolute value. All right? But we're going to do the same process. Okay? We're going to put a point at the vertex. You've got arrows on both ends, so it's going left and right forever, which means that the x is an element of all the real numbers. But here we've got a vertex at y equals 4, and now there are no points above that vertex. Okay, all our points are below it, which means that our y, our range, is y is less than or equal to 4. Next example would be rays. Now a ray looks similar to a line, but the difference is that it's got a stopping point. So the first thing we're going to do is we're going to label this stopping point. So this is at 3, comma 3. So an x value of 3, a y value of 3. Because it's got a stopping point there, that restricts both the x and the y values. Okay. So you it's got a stopping point there. The arrow here tells us that this keeps going on in this direction forever, off to infinity. Okay. So let's look at how we actually find the domain and range. What we're going to do is we're going to draw a vertical line through that point, and we're going to draw a horizontal line through that point. Okay. So what we're going to say is, okay, on this side, there are no points. So that means all of our x values are to the right of that line. Similarly, all of our y values are above it. So the domain are the x values, which have to be greater than 3, and the y values also have to be greater than 3. Let's look at another example with a little bit more room. Maybe it'll help make a little bit more sense. So we're going to label this point. This is point -2, comma 6. Okay, and you've got the arrow over here. So what that means, if we look at our x values first, okay, so the x value of this is -2. Okay. So what that means is that there are no x values to the left or less than x equals -2. All the x values are to the right. Okay. So since all our x values are to the right of that line, we're going to say that x has to be greater than or equal to -2. Okay. Now we're going to do a similar thing with our y's. We're going to draw a horizontal line now through the line y equals 6. And notice that there are no y values above that line. Okay. All of our y values happen below it. Okay. Which means that our range, all of our y values are less than or equal to +6. So here's our fourth and final graph type. These are segments. So with segment, now you don't have any arrows. You have a stopping point on both ends. Okay. So what we're going to do is we're going to label both of these ending points. Okay. So we got one ending point here at -3, -3. We've got another ending point here at 2, 2. Now, this open circle means that 2 comma 2 is not part of the function, which is important because that affects how we're going to write the domain and range. And I'll show you exactly what I mean with the next example. But the idea here is that we have constraints on our x values, which are just between -3 and +2. Then we have constraints on our y values, which also have to be between -3 and +2. So with a segment, it's almost like drawing a box. Let's look at another example. So once again, I want you to label both points. So we got the first point is at -7, -8. Okay. And the next point is over here at 6, comma 2. Okay. So here, let's start with our x values. All right. I'm sorry, I labeled that first point wrong. I misread my graph. Apologize. First point is actually at -6, -8. Okay. So if we look at our x values run from -6 over to +6. Okay. So -6 and +6, x is between those two. Now here, if you look at the closed circle, that means that we're going to say x is greater than or equal to, because that closed circle means that point is part of the function. Because the open circle is not part of the function, we strictly say less than. So x has to be greater than or equal to -6, but less than 6. Okay? That's a key thing to remember. If it's an open circle, there's no line underneath. If it's a closed circle, there is a line underneath. Okay? Now let's do the same thing and look at our range. Okay? So here, we go from -8 up to +2. Okay? So our range is between those two values. So -8 to +2. And once again, we've got the closed circle on -8, so we're going to say greater than or equal to -8. But an open circle on 2, so we're just going to say y is less than 2. Okay? So that's it. I know some of these can be a little bit confusing, a little bit abstract. So once again, please bring any questions you've got to class tomorrow. I'll be more than happy to answer them. We will spend plenty of time practicing these so you kind of get your hands in it and make sure that you understand how to set up the range, how to set up the domain. But that's all I got for you today. Once again, make sure you bring your notes with you to class tomorrow. And I will see you then.